Yeah, welcome everybody, and warm welcome not only from us, from FXCM as well. So this is the third webinar in a series of 3. So today I wouldn't say that we have kind of a finale, but we are going to put many important things together that are needed to do algorithmic trading. And at the core will be the RESTful API, which I demoed in the last webinar. So we will go today one step further and add automated trading to the mix. I have decided to not change the slide deck that much, so we will review what we have been doing before, and from this basis onwards, we will then see what we need in order to get automated algorithmic trading implemented. So this won't be kind of a production-ready system that you simply can use and deploy it in the cloud and then start running. But I think, yeah, it will be something like a milestone where we have all the elements together and see such an automated algorithm trading on its own. So this is the milestone that we will reach today, in addition to the first one with the RESTful API. And in the very first webinar, you have already learned how you can use FXCM tick data to do backtesting. So taking everything together, you should have the main elements in order to set up your own automated algorithmic trading strategy. Let me dive into my slide deck. So like usual, please read the disclaimer, the risk disclaimer carefully. Especially when you trade CFD instruments, there can be substantial losses, even losses beyond what you have put down as equity. A special situation holds true here in Germany. I'm pretty sure that you're aware of these risks, but nevertheless, it's always important to recap these and yeah, have a careful look every once in a while, at least. The agenda, I said it already, similar to what we have been doing in the last one, but with the major change in the live demo part, where we will add substantial elements to what I've been demoing before. So we will review how to connect to the RESTful API, how to use historical data for backtesting, what we can use with machine learning techniques in the trading area. I will then add to the story a very important element in the form of training versus testing of strategies. So here we need to be careful in order to not fall into the overfitting trap. And last but not least, as I mentioned before, a major milestone here, automated implementation of the strategy. I will make along the way some simplifying assumptions, and in particular towards the end I will shorten down the time interval we are working with, because this allows us to see it in real time and we don't need to sit kind of half an hour in front of the screen in order to see something happening. But I will mention all these simplifications as we reach the certain points. A quick overview of what we do. Basically, you find all the resources important with regard to what the Python Quant group is all about under tpq.io. But as a brief summary, all what we do is centered around Python for finance, for financial data science, for algorithmic trading, and also computational finance. And what I can say for sure over this year, the importance of machine learning and artificial intelligence in general has been growing tremendously, and I see this trend also intact for 2018. So artificial intelligence becoming more and more important, not only in our everyday life, but also here in our financial industry. If you're interested in how I look here, a picture that I typically use, you find also a wealth of information under hilpisch.com, like slides for different talks, also videos, also just GitHub repos, and so forth. So wealth of information, just visit it, all is free. Our flagship offering is the Python for Algorithmic Trading University Certificate, which we will now do in the 3rd round, and it is growing and growing, and we try our best to improve it over and over. So the next cohort will start in February 2018. So if you're interested, have a look at certificate.tpq.io. But getting back to what the main topic is, algorithmic trading, and a brief recap what is driving this complete field. And what we can say is that algorithmic trading is more or less developing in parallel to what other machine and deep learning areas are doing or trying to accomplish. When we have looked at the last part here, which says automation, basically, then maybe a general problem might be to build a self-driving car. This involves quite a lot of important and difficult things to solve, like vision and reaction and physical influence on such a huge thing as a car. We have it a little bit more easy when we think in terms of trading, automated trading. We need to place orders, buy orders, sell orders based on some signals. So this is still in the abstract world, if you like. We run it, of course, on hardware, which is comparable. We also do optimization training, learning, testing, validation, and so forth. But basically, we have it a little bit more easy, at least in terms of the implementation. Maybe not in terms of being successful. I come to that later on. And I will introduce you to elements in addition to what we have covered so far in this area. What is artificial intelligence, machine learning all about? Basically, it tries to replace our human brain, which has evolved over hundreds of thousands of years to what we now see. Our brain having substantial advantages vis-a-vis other animals. And artificial intelligence, machine learning in particular, tries basically to replace what we can do by some functional form, by some algorithm that can be embedded into a software system that is run on some hardware infrastructure. So be it a self-driving car, simply be it a server, or even a local machine, or your mobile phone. So this doesn't really matter in the end. So we will see more and more AI-specific chips coming to mobile phones and so forth. So this will be all around. Almost every device will be influenced in its design, software and hardware, based on what artificial intelligence is changing in all these areas of daily life, and also other special areas like our industry, finance, or let's say military and similar technologies there. One of the wonderful things is that basically with machine learning, we have what the author Pedro Dominguez calls here the scientific method on steroids. When we think back to Albert Einstein and all the other famous researchers that have come up with breakthrough milestones in science, then we have today maybe not their brains, but alternative means, machines in this regard, plus software, plus algorithms that can crunch through data and look for themselves, so to say. Every machine, be it a single one or a multitude like 1024 machines doing it in parallel and looking for something valuable in data. And this is kind of the fantastic thing that not even this is possible in principle, but this is also possible, let's say, for the retail algo trader. Even with your regular notebook that you might use on a daily basis, or your desktop, which is under your desk, you can make use of all the nice technologies that we are now going to cover and discover, and that are described, for example, in this book, The Master Algorithm, which is a very good read, and I can only recommend it. Having a look back to finance history, similar to science like physics, Albert Einstein, it was mostly brain-driven. People sitting down and thinking hard, using pen and paper, coming up with some equations. But contrary to the success stories in the hard science, as they say, we haven't had that many brain-driven breakthroughs that have proven to be of good use in financial markets. So this is what I want to show here with the inequality saying f of x doesn't equal y. When we say, well, the market gets some new information, has information, and y is the reaction. And what we would expect from such a model is that somehow when we feed in x, that we are able to at least approximate y, so the reaction of the market. But what we see now is that we have all the means mentioned before, where we have parameterizable models and we can train the models based on data. And then in many, many cases, and now I'm not speaking of financial markets only, but other areas as well, we can come up with something that is a data-driven and that at least pretty well approximates what we see as a reaction. So there might be something in it for us. So when we put AI in finance, what we call then finance, with the AI indeed included in the word. And basically, this is also what we are going to cover today, so that we in the end say, well, we have here markets and agents in our financial world, and there is some X, might be really, really huge. And the market and all the agents react to the news and to the new data, and then Y happens. And we try to simply replicate this via such a model. Basically, what people, for example, chartists have done for decades, that they say, well, if something happens, if we see some, let's say, pattern in markets, then we have learned over time that this might lead to a bullish regime afterwards or bearish. So it's not too dissimilar to what has been happening before, but now we delegate all these tasks to machines, because one of the major aspects driving all these developments is that we get more and more data. We used to have end-of-day data, now we have tick data, where we have, let's say, in half an hour as many ticks for a single stock as compared to 30 years of end-of-day data. So times are changing in many, many regards. Why Python for algo trading? There must be some good reasons. I don't want to go into the details here. You have them for reference, and this might be a good point when I mention reference to put the link here in the chat. Now that I hope everybody has joined, was able to sign in here, and I will put this in the chat so that you have access to the slides as well, with all the references and with all the links that are included in there. From a higher perspective, what machine learning and algorithmic trading need are a few major ingredients. The one ingredient is to have lots of data, historical granular data sets. So we need to have some kind of sandbox, a huge sandbox, more like a desert, full of sand, where we can train and work with the models that the machine and deep learning world provides us with. So FXCM is already doing a great deal here in providing tick data, and now also shortly available the RESTful API. So data shouldn't be of an issue anymore. So data is available. The second point is when it gets started in automated algorithmic fashion, you need to have access to real-time data, streaming data. So like, you know, it's kind of like the stream when you see a river and watch the river, lots of water is going downhill there, and we need this as well. And we need to have the latest data and not some data maybe with, let's say, 10 minutes delay. We want to compete with all the others in the market, and this means that we need to have streaming data. Also, the FXCM RESTful socket API provides you with this very important ingredient. Last but not least, powerful software and hardware to work with the data. I think this is also, to a large extent, commoditized. Commoditized in the sense that it is affordable even for the retail trader. And I think times have changed. 10 years ago, probably neither I nor anybody else would have said, well, that everybody can now afford to have what is necessary to do proper algorithmic trading. But I think we've come a long way with all the cloud compute and storage that's available, with all the open source packages and tools that are out there. So the barriers of entry in this regard, at least, have come down tremendously. Related to what you typically have to cover, we will once again focus on these 5 points. So we won't cover the infrastructure topic itself. It is one of the major parts of our training programs to teach people how to set up a proper infrastructure. And recently, I was asked a question for kind of a survey: what is the #1 thing that I think differentiates successful traders, algo traders, from others? And I said, well, at least when it gets to algo, it is about the infrastructure. People say, well, I get started trading on my machine back home, but maybe you need something, and this is not to talk about costs. I mean, you get a proper cloud instance on which you can run your trading algorithms starting from $5 US per month. So this is not kind of like a barrier anymore. Automation is also very involved in terms of monitoring, real time, and so forth. But all the other areas, financial data strategy, backtesting, connecting, and trading, will be covered in what we are going to do later on based on Python and the REST API. Just a quick recap, because it is so central. I've done this the last time, and once again, when I thought about maybe changing it a little bit, I thought, well, let it in here because it's that central. It doesn't hurt in cases actually to have seen it once again, because it's at the core of what we will use as the strategy. And I introduced this example with Amazon, where I say, well, person A liked book 2 and 3, person B liked book 1 and 3, and person C only liked book 2, and then there is a new book coming out, and we relate to this new book what the single person here is for. It's just a small set that I show here, have liked in the past. And we would say, well, maybe if we have another person E who likes book 2 and 3 as well, then maybe we should recommend the new book to this person in order to increase our sales. So this is how everything works. And you can replace Amazon by Spotify and replace book by song 1 and song 2, or you can replace Amazon by Netflix and you replace book by show 1, 2, 3, and so forth. So basically, this is all about pattern recognition. So we have patterns. Our first pattern is 0, 1, 1. Then we have 1, 0, 1. Then we have 1, 0, and 1, 1 once again. So here we have it, and we see that we might also have contradictory data here. But for machine learning, what we typically need is big data. Big data meaning that we probably cannot really work with these 4 data sets. We need probably thousands of these data sets. Sometimes, for some cases, millions, or sometimes maybe even billions of data points. This is kind of requisite to get reliable predictions, because here you see what shall the algorithm say. Here, the result is 1. Same pattern, but the result is 0. If we have 1,000 observations and we say, well, we have seen this pattern, let's say 200 times, and 150 times the person liked a new book, then we have kind of a probability estimate. And this is exactly what we are going to do. In financial markets, we try nothing else than, typically when we trade, to do some pattern recognition. So I speak of traditional trading, be it on longer term, midterm, or even intraday, where we try to discover something like head and shoulders, rectangles, and so forth, channels with breakouts and support lines and all these things. And basically, machines are pretty good at discovering such patterns. And not only at discovering such patterns, they might even, when we have a look here, they might in other data series discover patterns that we haven't really thought of. So the machine might have a neutral look and a faster look and might come up with something new. When we think of prediction, we have here the price level. This is from beginning of November, like a month ago. And we have here kind of the returns, but basically we are neither interested in predicting this line nor in this one. What we're interested in basically is actually that we know, or allegedly know, or hope to know that which direction the market will take. So we are all in this directional space, more or less. Of course, it is important when I assume whether the market goes up, for example, or not, how much it will go up. So, but the first thing, the first problem we need to solve is the directional one. And when we have now market data with regard to returns, you see here real returns. This is real data. I didn't come up with it. I took it out of the REST API. You see that we have, of course, positive returns, that we have negative returns, and so forth. So this is changing, and this is not really what would fit well with the classification algorithms that I showed before. So saying 0, 1, 1, so we don't have 0, 1, 1, but I think you get already the point with my coloring here. We have, of course, red, black, black, and red, red, black, and black, red, red. And this now gives already a pattern. And this is what we want to have in the data. We're just interested in the red minuses and the pluses here, but the machines typically don't really like to read minuses and pluses. They like to read bits, and bits are typically represented as zeros and ones, or maybe other integer numbers, which work similarly well. But here you now see that we have translated our stock market problem with historical returns and next day's returns to something that looks exactly like what we have seen with regard to Amazon Books. And I said, well, this will be the same with Spotify songs and with Netflix shows. This approach allows us to make use of all the nice algorithms that people from mostly other fields have come up with. So we can make one-to-one use in our field of what these brilliant guys have come up to solve their problems, to scratch their itch, and we can make more or less immediate use of it. Some advantages of using machine learning for algorithmic trading instead of, let's say, implementing our own rules might be that it allows for automatic pattern discovery. So we might think that head and shoulders is a good thing. This might have been the case, let's say 5 years ago or a year ago and even a month ago, but the machine might notice that this doesn't work anymore. So for example, but a different pattern we've never thought of might work much, much better. So this is the second part. It's easy to scale to huge amounts of data. So we might be able to analyze, let's say 2, 3, 5 instruments in detail, follow this on a daily basis, all the news and so forth. But a machine can easily scale. A machine can handle, let's say, 500 names at the same time, and also different configurations for the models that we apply to it. And basically, it doesn't need too much human intervention, so it's not too hard, like to seed it, so to say, and to let it run and to look for something. So I think these are really valuable advantages once you get all this implemented. But how to do it, and this is the major part now, is now shown in the live demo, and there are 5 points. You've seen them already before: connecting to the FXCM REST API, using historical data for backtesting, using machine learning for trading, training versus testing. I said it before, very important topic. And then, last but not least, the automated implementation of the strategy. So I will do all this live. I have a fallback as well, which is static, which I did just before the webinar, but so far it worked seamlessly, and I would expect this as well. Therefore, I'm changing here to my live notebook, where you once again see as one of the starting points the risk disclaimer. And I'm pretty sure I can increase this a little bit for better readability. So again, the first parts are kind of a repetition, but it's very important. And we have also done in the meantime a few improvements, some of which can be seen on the user-facing side, others more like in the backend. But it's still work in progress, and we work intensively to make it the best experience possible for algorithmic trading. So here I connected to the REST API, and the first thing is that I just retrieved the available instruments to get an overview. An overview in the sense of that it just lists the names of the instruments, the CFDs, and that I'm able to trade, access via the API, for which I can get historical data and so forth. So for me, it's always a test to say, well, I'm indeed connected. So Python doesn't complain, so it looks good, but I want to check whether it's indeed the case. So retrieving historical data is as simple as that I simply say con, this is my connection object, get candles, and I specify the instrument, period over 1 day, or just end of day closing prices. So we need to be careful when closing is and what kind of time frame is. And I say the last 10 available. So it's going here until 3rd of December. But there are other periods as well. You see, I've chosen here first just 1 day, but you see here a list of the elements that are available, and now changing to the time interval I will stick to, namely 1 minute bars. And when I have a look at the last 10 available, you see that this is really current now. So one thing is that here, this is GMT time. When you have a look at my clock on my MacBook, I'm CET time, so there's 1 hour difference, but it's basically the last available minute interval that is there. I could transform this to CET if I would fancy, but I stick with GMT because we have listeners and people here attending from many different areas. So GMT is the time. Once I have this data in there, I've showed this. This is pretty straightforward to then create some plotting. Plotting here, I intentionally have chosen just a small data set so that we have an easier time to see the candles. The larger the data set, the more I need to zoom in order to show here you the candles. And you see this, the blue candles indicate an upwards movement, the gray ones downwards movement, and the rest I think is self-explanatory for you trading experts. And once again, we see here that this goes until the last available minute. If I would now repeat this again, let me maybe simply do it here. You see already that I have, while I was speaking, I have now here received 2 more recent ones. So this is really online, so to say, online in the sense of that we get the latest, the last available data points. And of course, when I have updated this, I can then replot it and we see more current candles. I illustrated it already last time that we can add here some statistics. This is not our major part, but just to show that Python, and here I'm using Plotly and cufflinks, allows you to do some, let's say, chartist-like technical analysis as well, where, for example, I can put Bollinger Bands on and off here by simply clicking on the ledge. And this doesn't replace a proper trade application, but at least in this interactive environment, it allows you to easily interactively explore your data sets. So this is what we can say. Now we come to the point where we start using machine learning for market prediction. And when I introduced this during the last webinar, it was mostly intended to combine a machine learning algorithm, and in particular support vector machines, with the historical data. The results that I've shown have been, I would say, impressive, or maybe just a little bit short of impressive. But I didn't really get into important topics like saying, we have trained the model on the data set, we have tested it only on this data set. So we should make sure that whenever we rely on such a model, that it proves robust. And robust typically means that it performs out of sample as well. So this is a very important part of the whole story that I'm now going to add here to the functionality. So where I use machine learning for prediction, you see here still, this is all simplified and for illustration purposes only. So we are not considering transaction costs, but bid-ask spread and other important parts, but still we will add some really relevant twists to the whole story here. After some Python imports, I now retrieve the 1,000 most recent 1-minute bars. So the data set is now a little bit larger. I'm not mostly in visualization part anymore. I pick out just 2 columns, and here, just to give you a glimpse, these are, now you see here December 4th, December 5th, starting midnight, and this is once again, let me have a look at the last minute bar we now have. Oh, unfortunately, I cannot see it. Let me simply inspect it, data tail, so to see what we have here. So mid-close, the last point is now 12:29 GMT. So this is the last one that we have here. And once again, if I would retrieve this over and over, I will be able to update the data. What you see is kind of more like a sidewards moving chart there. Now the features. You remember, we are in the business of recognizing patterns. And in this regard, let us derive our patterns based on lags, so on historical return lags. first is here that I calculate the returns. The second is that I'm using here 8 lags. So depending on the results, I might go back and use more or less. Here, this is, I would say, still more an art than a science to define the number of lags, but I keep it simple anyways. I could include here things like simple moving averages, RSI, or all the traditional indicators could be included here as well, because sometimes I get approached by people that say, well, but I prefer to still work with my, let's say, simple moving averages or exponentially weighted moving averages. But I say, well, you still can do this. Machine learning just adds on top of what you today use typically anyway. So there is no need to sacrifice anything to be able to use something else. We could here, but I don't do for simplicity reasons, we could include other statistics as well. So not that a big deal. But for the time being, I'm just working here with the simple returns. When I visualize this, and you recall this plot from my slide deck, once again, we are mostly interested here in the red dots. So this is the absolute level, and the absolute level, this is mostly what we see here. So this is the absolute level, just the last 100. The returns are the green ones, and we transform this here to just market direction, up or down, up or down. So this is what we're interested in. And when I now use my lags that I mentioned before, and I show you the data set, you now see that indeed I have my patterns here. Interestingly enough, I have the first pattern with ones only. Then here we get a 0 in the row. And here you see how this evolves over time. So if you say, well, there's not that many patterns, of course, we have more here. Now I'm showing you 100 such patterns for 100-minute intervals. So we have quite a bit of a data set here. And I'm not even showing you the whole data set now. But once again, these are now the patterns for which we want to say whether such a pattern more probably leads to an upwards movement, or if it's more likely that we will observe a downwards movement afterwards. And you see that I'm translating this into zeros and ones, like as I pointed out before, our bits here that we can use and that the machine can easily understand. So in that sense, when we work with here 8 lags, we have 2 to the power of 8 combinations, which means we allow for 256 patterns. And the machine will analyze 256 patterns. And we'll see whether it can learn which pattern with certain probability predicts an upwards movement and which patterns with a certain probability predict downwards movement. So here it's 256 patterns that we allow for. When I go back to the one slide where I had the patterns, actually here you see on this little chart we have 12, 14. So here are just 14 patterns mentioned. Maybe you can say, well, they are over longer time or whatnot, but this is not the basic point. So we try here to get a little bit more granular and allow the machine to analyze more patterns that we typically can even memorize, not to mention can spot in a huge data set. But the machine doesn't have an issue to spot whether this particular pattern is in our data set to be found like 10 times, 15 times, or 25 times. We would be having a hard time to spot this. There's a question. It's a question with regard to Seaborn. No, Seaborn is not the pattern recognition module. Seaborn just defines how this plot looks. So this is just a style. I will introduce the pattern recognition module in a second, which is called scikit-learn. Yeah, but please ask these questions if you wonder what certain things mean there. There is now a question which I don't fully understand, to be honest. Is the machine an AI? Maybe you can elaborate on what you mean by this, because any AI probably is based on some form of machine. I like to talk about the machine comprising the software, the data, the hardware, and probably some interaction mechanisms like being connected to the web. But maybe you can specify a question. Now I'm introducing what I'm going to use for the pattern recognition. It's the same algorithm. It's called support vector machines. We don't have room here to go into the details, but basically such an algorithm allows you to train a model which then is able to create predictions based on patterns. Once again, exactly what we human beings try to master in the markets. We try to learn about patterns and what we can judge based on the discovery of a pattern. And the machine does the same thing, but it does it much, much faster. So that's the basic advantage. Much faster, meaning here, once I have imported the module, have set up the model, here the fitting procedure takes place. Given the data I'm using and the parameterization, it takes half a second to train the model. So the model on the complete data set, which is, maybe I show you what the data set is about. So data info. This is what the data set is about. This is about 100K, and we have 991 data rows, so it's still not huge. But still, for us human beings, that's already quite a bit. So we see lags number 1 to 8. This is where the patterns are in, and the returns are the ones that we try to predict, but just with regard to the sign. And when I speak of prediction, you see here, once I have my fitted model, so here's the fitting, half a second, I can use this model and predict now in sample market direction. So you see market direction here being transformed to some machine readable numbers, meaning -1 would imply short position, +1 would imply long position, and so forth. So this is already now based on the model. It gives us predictions, and I'm showing you just 50 numbers. So I could show you 150 numbers, and you see that it indeed does it for the complete data set there. We can also, and I think this is something that that people relate to. Here we let the machine do the prediction, but the machine uses some form of probability. And frankly, this is just taking half a second because I've set the parameter here to probability true. This takes a little bit longer, but what I gain by that is that I can also predict probabilities. So here you see that I use predict proba, and here are my 3 classes, -1, 0, and +1. And here you see a selection of the probabilities. And the probabilities here are to be read like for the market moving down or up or staying at 0. So we allow for 0 here as well, because we have zeros in our data set. So we can not only say, well, please machine, tell me up or down, but we can look up with which probability mass the machine is predicting a certain movement. So I think this gives, for us human beings, if somebody says to you over lunch, our research department has figured out that with a probability of 80%, the market will go up tomorrow, I think this is a different quality than just saying, well, our research department has figured out that with a probability of slightly above 50%, the market will go up tomorrow. I think you would judge both messages a little bit different. And in that sense, we could also have a look visually at the distribution, and you see here that we get full access to all the probability data that we have in here. So first I think, valuable addition that we introduce beyond 0 and 1, beyond -1 and +1, now kind of the probability view with which we human beings can really work well. We have a feeling for something like this where we say, well, I go to the casino, and if I think I have a 55% probability to win, I'm more probable to play than when I think I have just a 40% win probability, to make a rather extreme example. But the same holds true, of course, for the financial markets. We have a trade idea, and of course, our judgment with regard to the probability plays a role with regard to our implementation, like the money we put down, and how long we wait for it to materialize, and so forth. So there's one more question with regard to the whole approach. Why do we use lags? Yeah, because lags are something, again, I use this chart, so I'm always resorting to something that has nothing to do with machine learning, because what we typically do in financial markets is that we have a look at historical data and say, well, after we have seen head and shoulders in the markets, we would expect the market to go down further. Or when we see kind of a breakout out of a downward channel, we would see the market going up, or like ascending triangles or so forth. So the same holds true for our machine learning rational. So when I get back, where we say we work with historical lags. So these are the ones that I'm showing here. This is 1 day back, 2 day back, 3 days, 8 days. We could go 20 days back, 100 days back if we fancy, but the models are not that robust anymore. And basically, once again, it's the same thing that chartists and other analysts do. They have a look at historical data and try to recognize a pattern and then come up with kind of a trade idea. Because, to be honest, I mean, we just have historical data. We can now debate what kind of historical data, or rather current data, but what we don't have, what nobody has, is kind of the future data. If we would have this, I'm pretty sure we would save ourselves for writing such code here to come up with some reliable estimates. Yeah, there are kind of, I'm just having a look at the questions that have come up in between. Yeah, like trade ideas based on software. Here it is, there is a really technical question, what kind of activation function is used. Frankly, I would need to have a look at the activation function. Here, I'm pretty sure that there are multiple available, but something like softmax or sigmoid or whatever is I could think of, but this is something you typically can also adjust in the algorithms. Whether you can, there's another interesting question. We've been working on this for quite a while, to mix data like daily historical with weekly data. Of course you can. It's not that straightforward to mix data from different time frames, because you need to make sure, of course, that in the end it is all working out well. But of course you can mix data. That's not the issue, but you need to be aware of what you're doing. So that's the most important thing there. Yeah, there's this brings me to my next point. Now we're getting, there's a question asked whether we can check how often the probability prediction and the prediction itself turns out true. And I will show you, let me, here below there, we will have a check for that. Here, accuracy score. So bear with me for a few more cells here, and then I will show you the accuracy. So now getting to the vectorized backtesting, I'm putting the prediction values into my data frame, calculating the strategy returns and plotting it. So this is what I meant by kind of spectacular performance in a sidewards trending market. Here it's all euro US dollar. We have this green line which more or less linearly goes up. But once again, I said this is the trap many people fall into, and this is not something theoretical. There are many, many practical examples when people started trading their strategies that were wonderfully working in sample, which means on the very data set they have trained it. And you see here, for me, it's kind of pretty easy, not even applying some tricks, let's say, or improvements or more sophisticated algorithms to get a really good performance relative to my benchmark. So green would be my strategy, blue is the benchmark. But of course, there are some technical issues that we say, well, I'm using the complete data set to train it, then I go back. So I use these data points and go back then and start trading with implicitly knowing what the future will bring. So of course, that's an issue, but that's the starting point. If we wouldn't even see something valuable at this point, probably we would try to change the algorithm or our overall approach. So the positioning here is more short than long. We see we have over our period 991, we have 528 short positions, 440 long positions, and 23 market neutral positions. Yeah, there's another hint. I said it before. It's simplifying assumption. It's we are not placing some stop loss. What this strategy is about, that it's minute by minute checking the positioning. So it's not something that we would let run for ages if losses would accumulate. But this is something that can be included here as well. But again, this is the, let's say here, the red warning at the very beginning. So it's worth maybe going back. Among others, also not transaction costs. And if we neglect transaction costs, the trade frequency, of course, is of high importance. Also the bid-ask spread. If there are no proportional fixed transaction costs, of course, it's bid-ask spread in this regard. So this is kind of kind of clear that a couple of elements are missing. But I decided to focus first on the more important ones and the most important ones, so to say. Later on, we can do as many refinements as we like. So yeah, it's always kind of the question: what are a good hardware requirements? First of all, I would think that to get started, the machine that you use on a daily basis, and I assume that you have such a machine because you're following right now. So some machine might be already there, should be enough to get started. So the hardware requirements to do what I'm showing here are not kind of huge. I mean, I have a MacBook with decent hardware, but this wouldn't even be needed to show you what I'm showing here. The other thing is that I always recommend, once you get started with real money, you should make sure that you migrate your trading logic on a professional infrastructure. Once again, something we focus on intensively in our training programs because it's so important. You cannot make sure that, for example, if you run something 24 hours a day, that there is always internet connection, that your machine is always up and running, that there is no electricity outage and so forth. If you run your stuff in a professional data center, you get all these elements, so to say, for small amounts of money, like $5 US per month as a starting point. You get fire protection, you get physical access protection, you get redundancy with regard to electricity, you get redundancy with regard to internet connection, you get fast internet connections and so forth. So I would really recommend to use something like DigitalOcean, for example, easy to start, or the bigger providers like AWS, EC2, Amazon. So these are for sure good choices, but we use DigitalOcean because it's, from our point of view, easiest and also really reliable alternative in the markets. Yeah, there's a question with regard to sharing the Jupyter notebooks. Currently, it doesn't make sense to share it because you cannot use it. So, but in the chat, you see already the link to FXCM's REST API demo offering. So there is now the option that you can apply for the demo offering, and in the course of that, we can then provide you with access. Because otherwise, you just see what I'm doing here, but you cannot execute it. You cannot make use of the Jupyter Notebook project. But we are just before the point where you can make full use of it. So not too far away anymore in this regard. But now let me add this one very important element to the story, where I now say, well, here this is too good to be true, and it is too good to be true in terms of a realistic performance. Therefore, what we now do is we take our data set, and admittedly, we still have a small data set here, but I just wanted to be able to visualize everything. Therefore, I work with a small data set. And now what you see is a little bit of technical code here, but the basic message is that I split the complete data set in half a training data set and half a test data set. Meaning, but this is happening randomly. So usually what you can do is that you say, well, I train my model based on data from the first half of 2016, let's say. Then I take data from the second half of 2016 and test it. This will be one approach. Here I'm using a randomized approach where I train it on randomly selected 50% of our population. This is my train data set, and the other 50% are used for testing. So, and speaking in terms of pattern recognition, I now implement an approach which is a bit more granular or exact. I'm not using zeros and ones anymore. I'm now using a few more categories. So you see we have zeros, ones, twos, so we don't see a 3. Maybe let me have a look. The data set doesn't show a 3, but it is parameterized, but this depends on the data set, so we cannot force it to show something when the data speaks a different language. And you see now from this train data set, we have 55 minutes, then 56 minutes. So there is one in between that is missing. So it's randomly selected here from the original data set. And we now have 4 different classes or categories, and 4 to the power of 8 now allows for 65,536 different patterns. So this is the number of patterns we are now working with. So it's quite a bit. This can be good or this can be bad, to put it bluntly. But I thought I introduced it here to show you that we can get a little bit more granular. And basically, what I have been doing here is that I say, well, do we have a, let's say, regular return, which is regularly positive or negative or really high or really low? So we have simply more categories that we built. And now the model fitting and prediction, you see it's done on the training data set. This is the prediction. And then there was the question, and now we have arrived at the answer to the question. What is the accuracy? And you see here on my training data set, I have 92.5% accuracy. So this is pretty well. But now I take the same model and test it on the other data set, which was not part of the training exercise. And you see, from 92%, we are going down to 48%. We can now visualize this whole story when we do the same thing now on the complete data set. And I'm now showing you once again in sample. In sample meaning the data we trained the model on, we have similar performance to what we have seen before. Out of sample, well, this is performing well towards the end, but in the beginning you see that we have a mixed performance. So this is, I would say, ideal. I would better sleep or go for lunch with the strategy that performs like this. But here we happen to have let's say, also a decent outperformance of the strategy, or of the strategy compared to the benchmark, but it is a mixed performance. It's not kind of this close to linear evolution there. But nevertheless, we have a positive outcome, and once again, a little bit of a support that there might be something in it. Not saying that you should apply this one-to-one. By far not. There is no investment advice included here. This is about technology. There's another question, an interesting one. So how is market news included? So far, we have just worked with historical return data. I said already that the approach here is not by any means constrained to the use of historical return data. We can, in principle, include whatever we like. So here's an example made by recent Britain's intervention on cryptocurrencies, or whatever. We have seen similar interventions by China and others. We could have some natural language processing algorithm running all day, checking for such news which might be relevant to the instrument we are trading. Probably we wouldn't like to monitor everything. And we would include such data into our reasoning here as well. Reasoning meaning it would be another feature column. Instead of 8 feature columns, we might have, let's say, to make it simple, a 9th feature column, which would then say sentiment about, in my case here, in our case, euro US dollar, positive or negative, given on our analysis. But this is, be assured, I wouldn't say easily accomplished, but technically not that big of an issue. So many people do this already. Well, there's another question, which is maybe this already answers your question. If I want to select multiple columns from a data frame object, this is a technical Python one. We don't have a Python training class here, but of course we can answer that. If you just want to specify the column names, you can do this in the form of a list objects and strings. So this should be easy enough, or maybe I'm not getting the question in full. So just now to show you another way of going about it, once again, we have the 3 classes and we have our probabilities here that I showed before. And we see the probabilities, they vary. They vary kind of here. We just have these maxima for what we have trained. And I could now say something like, if the probability to go short passes a certain threshold and the probability for market neutral is below some threshold and so forth, then do this and that. So this is, yeah, given the technicalities now, something where we say, well, we can work with our strategy also with the probabilities directly, and can implement our rules there. But you see here now the probabilities. This is one problem, not of the implementation, but rather how this is presented to us. So this was, I just needed to change the sign, because sometimes scikit-learn presents the probabilities for upwards movement first, and sometimes it presents it for downward movements first, and therefore the algorithm needs to be adjusted. So in sample, you see the performance here, which is not too bad actually. So we get up to some 5% for our in sample, and out of sample, I don't know. Out of sample, you see, oh well, this rule doesn't really work that well. In particular, it leads to what we see here, to quite a bit of volatility. But nevertheless, it's not deteriorating. And tweaking and improving the strategy, adding more elements, probably would improve the performance out of sample there as well. But once again, still all simplified. Now let me do a quick run through, because this is really a recap. Now retrieving and maybe not visualizing here. So I here just do the retrieval part. When I get started here, and after just a brief delay, you see that I can retrieve data here in real time. This is now market data. 1 p.m. We have 2 p.m. here Central Europe, but this is in real time. So I get also the whole bunch, and I can unsubscribe. So this is one major element we now need to be able to implement an automated trading strategy, because we need to be able to digest data in real time. This is a conditio sine qua non, so to say. We can also, and I've shown this already, place orders. And here in this part today, I'm just focusing on market orders. So you see, when I start here with Quant get open positions, there is no open position. Therefore, I don't get an output. I just wanted to check. And here, this is something we implemented just recently: create market buy order, provide instrument. And here, this is in thousands. So 100,000, one lot. When I execute the order, I have this order object, get currency. This was euro, US dollar. It's a long position. And when I look this up, you see that my open position, which was empty before, now shows me the trade ID, the amount, here K in thousands, currency, and my current cross P&L. I can create another market buy order, this time for the US dollar Japanese yen currency pair. And with regard to open orders, I see now a second open order. I can move on. So here you see I'm now more behaving like a day trader. I say, oh well, let's sell out my euro US dollar position, but not completely, just partly. So here I've bought 100, but here I'm reducing my position by 25. But I'm increasing US dollar yen by 50. So I would expect 3 positions now exactly, because we see the 2 long ones in US dollar Japanese yen, and we see the long one reduced by 25. Then I can say here once again market sell order, further reducing euro US dollar, and now being by 25 only. You see, this is the rest. And when I now say, oh well, let's something happens or whatever, I want to finish trading, close all for symbol US dollar Japanese yen. I have 2 open positions, and after I've called this, I'm just left with euro US dollar 25. And if I want to close them all, I just call close all. So these are convenience functions that we have implemented. And as the name says, that I was just using, they are for convenience. You can achieve market orders by different ways, but here market orders are simplified by setting some default values for what the API expects. So we have streaming data. We have seen how easy it is to place buy and sell orders. And now let's put all these elements together. Our strategy that we backtest, that we fit based on our data, and that we then use to come up with market predictions, which then lead to buy and sell orders. So this is now the final part here, where all the elements that are needed are shown in a single little project. But I make a simplifying assumption in between. I will show you what is happening. So first, here I only work with 3 lags so that we don't need to wait that long. So I work with 3 lags, just 3 lags. Here is a little helper function, but it doesn't really present something new. It's more like that we can use it a few times. This is exactly the same thing that I did before. 1,000 1-minute bars. Then I do this little transformation. And here I create, via my newly defined function, now the lags. So when I have a look at data head, for example, you see that we have mid, we have returns, now we have our lags. Just 3 lags, very simple, just straight out. I want to focus here on the technology side and not on something else. So head, or maybe I should rather show you tail to see that we have the recent data here included. So we just trained the model on the most recently available data points that we can get from the API. Here we fit now the model fit on the returns. And with the fitted model, I don't do now test, train, and so forth, because the test is now in applying it to practice. So this is what we do. But here I just wanted to show you, of course, our model allows us to create market predictions. So this is what we have been covering in the first place. Yeah, that's the point. The question, import FXCM, somebody asking where can you see the code? This is not yet published, so you probably need to wait a little bit until it's published. The code is not yet out there, so not official, so to say. We need some internal discussions and need to put it in a central place as agreed upon. But once again, it won't take that long anymore. There's another question with regard to options trading. We don't cover options trading here at all. Options trading, of course, is a little bit more involved. Other rules apply, so to say. But with regard to the strategy, I'm now in the middle. So in the middle of a straight out strategy, I'm now about to show you. So yeah, of course, you can after this is all in the public domain, so it will be available as open source. Of course, the technology itself is proprietary, but it will be out there as open source. You can use like what I'm showing here for your own algorithmic trading projects. So, but here, when I move on in my project, my little project, so this was, if you like, the gist of all that what we have done before. So I retrieved the data, I trained my model. Here I show you the data, and here the model does some prediction. Now, when we get started trading, when I have a look at my data set, this is the last available data point that I have. And in trading, I will now say, well, have a look at the last available pattern, so to say, and use this lastly available pattern, so to say, to come up with some prediction. And here, given the model, if this would indeed be the last pattern that we have in our data set, then the prediction would be -1, and we would go short if we wouldn't be already short, and so on and so on. So this is the basic idea. We always have a look at the last combination of historical returns, +1 or -1, and then create the prediction. So now the automated implementation, don't be afraid, what is coming now is quite a bit of code, but not too much code if we consider what this is all doing. So here I've set up a second connection, and I'm initializing a few elements here. And this is now the trading code. So I will guide you through this quickly because it's quite a few lines of code, but it's not complicated code. So sometimes when you see 12 lines of code with a sophisticated algorithm, it might take you hours to understand what's going on. Here, I think if you have a little bit of background knowledge with regard to Python, it should be rather straightforward. I have tried to add some headers here as well. In the beginning of this function, we just define some global variables, and we do a little bit of a printout. So this is just for every tick data point that we retrieve, and we have seen this already in action. And here I'm just, every 5th tick, I'm printing out what we retrieve. But this time, I now collect all the tick data in a data frame so that I have it available throughout. I do a resampling to a 5-second interval, and I will work for my trading signals based on this 5-second interval. So here, when we have enough data together, when the collection has been running for a little while, then I start generating signals. So here, signals are generated. And from this on, I think you now get the logic. Here we get the data and print it out. We collect it, we resample it, we create a signal, and then we distinguish a couple of different options in the sense of that we say here, let us check whether we should enter a long position. And we have basically two options. So either we are market neutral and we are going long for the first time, or we are short and going long after the short position. So these options are valid ones. Or we enter a short position, the same story. Either we are market neutral and we enter a short position for the first time, or we are long, and here this is redundant, we are long and we are going short afterwards. So that's the basic idea. And here I stop it from the 40th tick in order to not have it run too long. And in that sense, you see that we have now all the elements together. To do this, here, if you have missed it, here we use model. This is our fitted model to do the prediction. And from this on, this if, elif, just checks what position we are in and what we do. So I could even, I just noticed I could even simplify this so that you are not afraid of the number of lines here. I don't need this straight flag. I used it before to check something. So in that sense, well, few lines, but not too many, given what we want to do here, namely using artificial intelligence in the form of a machine learning algorithm based on our just retrieved data set, which is, so to say, up to the minute, to which we fit the model and then go on, collect current data in real time, resample it, and create signals in real time. So I think given this endeavor, this project, it's not too much code to consider that we see here. So, and this function, this callback function, is now used here when I subscribe to market data. And let me get it running. And you see here every 5th tick, I get a printout, and here we have collected the tick data already quite a bit. We have also resampled data, 5-second intervals. And we are now waiting for the first order to be placed here, going long for the first time. When I now check here, you see that now we have an open trade position. So it went long for 25. So I'm just trading 25 plus or minus. And we have reached already 40 ticks, and it closes out all the positions. So we've now seen in a rather short period of time all the elements, namely here, getting started, having the model as input. We collect data, we resample the data, we use the model for prediction, and then check the positions and create orders. Maybe I go here and let it run a little bit longer, let's say for 100, because we have a few minutes left. And I need to reinitialize this here so that we see what is happening. In the meantime, yeah, there's another technical question, how to connect to the stream, and you see how it works here. We have this connection object connecting to the REST API. We subscribe to market data for Euro, US dollar, and we pass in a callback function, which does something with the data. In our case, you see here, we're going long for the first time. We've collected tick data. We have resampled data now with lags and prediction. And we have, in the meantime, we have an open position. So exactly via FXCM, via this connection object, you connect to the stream API. There is a performance question whether the data frame would grow too large and slow things down eventually. Of course, this here is meant to be a demo. So during this demo, I now call this to show that we now have a short position is by default. We now have a short position here. And this, of course, assumes that we won't collect that much data. But to be frank, we had the discussion with regards to proper hardware. If you are working on, let's say, somehow decent hardware, I wouldn't see data frame in-memory performance issues popping up that quickly. What you could think of, now speaking technically, is that one process collects the data, provides it to another process, which creates the signal, provides the signal to another process, which executes the trade. So you could even go in parallel with all these things. And most probably you also want to make sure that now it's trading quite a bit because it's changing up and down. So it's a good example that we have here. Because you want to probably collect and save the data as well. So just think of some in-memory issues that might arise. And you might lose data that you have been used for trading, and in that sense you might save it to a database file as well. So this here is just for illustration, and you see for sure there are not that many issues when we have just 100 ticks to manage. But with, let's say, starting from a few 100,000 ticks, there might be some issues. But now we have seen here a complete run through. Here in the beginning, we just have a few ticks, not enough to have our lags here filled and be able to create prediction levels. Then from a certain point on, we get the first trade. This was here after 15 ticks, going long for the first time. Then you see here going long. There was a short trade in between, which I deleted here, going long, short, long, short, long, short. And the last thing that you see here is closing out all positions. So most probably you don't want to have that many trades as we have here. You want to adjust your strategy for the number of trades, and in that sense, transaction costs, bid-ask spreads, and so forth. But I have intentionally chosen here the parameters to have 3 lags only and 5-second intervals to be able to show you this in a sensible amount of time. If I would have chosen this whole thing to be on a 1 minute or 5 minute bars with 10 lags, let's say 10 lags, 5 minute bars, then either we would have retrieved the data from the REST API, which would be another option, or when we collect the data here in real time, maybe intending to do something else with it, then we wouldn't have needed to wait for like 50 minutes, and nobody wants to wait here for 50 minutes until we see something. But so now you see kind of a nice walkthrough with all the ticks that we have retrieved over time. We have now updated data here. So in my resampled data set, you see kind of predictions, long prediction, long, then it changes to short. We change the position given the patterns, and here you see exactly the pattern. This was kind of the pattern which led to this prediction. This pattern led to this prediction, and this one to that one. So exactly how we would expect it. There's a good question with regard to transaction costs. So of course we cannot cover everything here with regard to our certificate program in Python for algo trading. I think we are now close to 150 hours of instruction that is included in this. It's hard to put all this in addition to the REST API into such a relatively brief webinar. I focused on the most important aspects. With regard to the implementation, transaction costs are implicitly included. With regard to the backtesting, there are multiple approaches that we teach, even with regard to exactly accounting for bid-ask pricing in that regard. So bid-ask spread can be accounted for also in vectorized fashion kind of easily. Yeah, there is another question with regard to the API. I think this is one that it's probably best answered by people from FXCM that are kind of really helpful here, working in the background, answering questions. I'm really grateful for this. So we can answer all the questions here almost in real time. But I would say that of course, this is a new project. This is, I wouldn't say in its infancy, but it's just about to be published, to be released only. All the other technologies are well established, and this will be some well-established technology sometime soon as well. And sometime, I mean, more on a weekly and monthly time scale, not later. And I think it will get quite a bit of momentum because it's a modern approach to get started here. It's also due to the Python support, something that many people are waiting for. I know this, so I would see many amazing stuff around here as well, but also around the other areas in this regard. There's another technical question. It's a little bit involved, and frankly, I don't really have an immediate answer for this. Working with strategy. Here for the demo, this is also one thing. I've been working in this demo with a data set. This is simply going 1,000 minutes backwards. So I didn't even tweak it to have some nice case. So I just take the last 1,000 minutes. If I do the webinar or would do the webinar tomorrow once again, I would maybe also use the last 1,000 minutes. But of course, my data set would have changed considerably. And of course, if you wanna see how the strategy performs in different scenarios, different regimes, based on different data sets, there is a need to fix it. So here I have this one moving piece there. Therefore, I cannot really answer in this regard. To show the results of the demo, I don't even know what this meant by the performance probably. So I would assume that since I was trading that fast, that ask would have eaten up everything that I've been doing here. So to put it bluntly, but I'm not even recording here at this point performance of every single trade. So, but once again, this is not to say that you should trade that way. This was all the parameters that I've chosen, 5 seconds, 3 lakhs only were chosen so that I was able to show you something here without everybody leaving or falling asleep. So now we saw action, so to say, every 5 ticks, we saw another trade, and this is what I want to make sure that we see kind of a complete cycle here implemented in a few minutes only. Okay, I think for the time being, these have been the questions. Let me quickly go back here. Move forward once again. So we have seen this all now in action based on data, and in particular based on live interaction trading, execution at market, and so forth. So I think with regard to the toolbox, we have now everything together to get started. Of course, other market orders, entry orders, and so forth are also possible. OCO orders is all possible, but I wanted to focus here on the automation aspect, in particular in the 5th point. It was already posted in the chat, but there is now the webpage with the new FXCM API offerings. You find the link there where you can register based on your account for the new demo API. Feel free to reach out, also to reach out via the email address. So probably, or maybe the people from FXCM can put it, the organizers can put it in the chat once again so that you have the email address there as well. Exactly, here we go, education@fxcm.com. Fantastic, and yeah, feel free to reach out. It's not to 100% there, but we are working all day, we can say. So I can say it from our end to make it as good as possible, and also in a let's say a period of time that you can make use of it rather sooner than shorter and not have to wait for another few months. So I'm pretty sure that internally this is also the same idea, and we are hoping to amaze you with a new API to the extent that we wish for. But I think many good things here on the horizon, bringing me to the end with mentioning the horizon, and a few questions like usual pop up. This will all be communicated. The place where you find the information, the background, there will be a GitHub repository. It will be pip installable. So the whole infrastructure around it, will be made available in, let's say, benchmark fashion, professional fashion, if you like, so that you have an easy time to get up and running. We will also provide tutorials. We will provide documentation. There will be Jupyter notebooks for you available. But once again, it's not yet out there. I cannot point you to the GitHub repository where you find it because it's simply not yet published. But once again, and I repeat myself here a couple of times, it will be out soon. So bear with us and watch out for what we will bring out there. Thanks to everybody. Yeah, I think time to close. I was just looking for the last time through the questions. I think they are now all answered. And in that sense, it remains for me to wish you happy Python coding, happy algorithmic trading, and in particular, take care. Bye-bye. See you next time. Bye-bye.